So I think I said in the last video that we would jump into the axioms. That's not true. Actually, there's this topic of classes that comes before that. And so classes are a lot like sets in that they are collections of objects, and but they are not equal to sets. They're not the same thing as sets. We will use the notion of classes to state the axioms. It just kind of is a device that makes the statements of the axioms a little bit easier. But the axioms will actually give us the rules for which things we are permitted to call sets, and nothing else will be. So like I said, classes are collections of objects, but they are necessarily those collections of objects that can be defined by a formula, which we typically denote by phi. Now, what is a formula? A formula is like anything that you may have encountered in first-order logic, except that the relations used in the formula must be either inclusion, set inclusion, or class inclusion, or whatever, inclusion, and equality, where those are primitive concepts that are not really further defined in any sort of meaningful way. And then also we get to use all of the first order operations, conjunction, negation, so on, the quantifiers for all and exists, and a free variable u, and perhaps, if desired, a constant p. Now, if you sort of compose those in the right ways to get a well-formed formula, as we, know how that goes in first-order logic, you get a formula phi, and then you can take the collection of all objects satisfied by this formula phi. We call that a class. So that's the topic of classes. Next video, the first axiom of extensionality.